All right, here's part 2 of my chapter 6 test review. And this is something I didn't spend a whole lot of time on talking about in the videos because we've done it so much with quadratics, but I'm going to talk about it here, and I'm going to talk about a few ways you can find all zeros. Zeros are the same as solutions, are the same as what we called roots. On a graph, we call them x-intercepts. So all these things are important parts, or they all mean zeros. So if you're asked to solve or to find zeros, find roots, find x-intercepts, you're doing the same thing. And ways ideally that will do that is factoring. Now the problem is, what if it doesn't factor? So let's look at this number 11, and I see 4 terms. So I'm going to try to factor it by grouping. So remember, 4 terms, kind of groupings jumping out at you. So if I group these 2 terms, I get a GCF of x squared. That's great. And then I'm left with 3x minus 2. And then if I group the next 2 terms, I can get out a negative 2, I believe. So I get a negative 2. Oops. And that's going with 3x. It's going to be 3x plus 2. And this is a problem. So these groups don't match. That one has a minus, that one has a plus. That means they're not the same factor. Even if I would have chose to take a positive 2 out, that would have made this 3x negative and this one negative. So I still wouldn't have had matching signs. So here's an example that does not factor. So, well, what can we do? If it doesn't factor by grouping, well, maybe we can use division. And you kind of think to yourself how you did the other problems, or the problem from the last video, from part 1. We factored here because we were given a factor. Problem in number 11, we're not given a factor. So let's think about, well, what can we do? Well, if I was given a factor, I could have solved this. I could have set each of these factors in this black box equal to 0 and solved, right? I could have set x minus 2 equal to 0. That would have gave me 2. I could have set x minus 3 equal to 0. That would have given me 3. I could have used quadratic formula on this guy. That would have given me 2 imaginary solutions. I don't have that factor, but if I could solve it, that means I could have x-intercepts. So here's a little cheat. I used to, when I was your age, I'd do this long process where you kind of guess and check till you found a number that worked. But we're going to cheat. So what I did was I typed this function in a graph. So here is, let me see if I can stretch my screen out. Well, the function's over here on the left. You can't quite see it, but here's the graph of that polynomial. Just a review of graphing. We knew it would kind of look like this squiggle. I could show you the whole thing. I knew it would have this shape. I knew the end behavior would be pointing in opposite directions. And then now I see on the graph, we have a nice x-intercept. So here's a nice x-intercept at 2. What that means is the factor x minus 2 would have given me this. So now I do have that starting point. I do know a factor that goes into this. I know this has a factor of x minus 2, and that's because it had a 0 or an x-intercept at 2. It's kind of like working backwards. So let's divide this out and see if that helps us. So just like the previous problem, I'm going to divide out that x minus 2. And I'm using synthetic. And I drop my first coefficient, I multiply, I add, I multiply, I add, I multiply, I add, right? 2 times 2 is 4, I add, I get 0. And again, we're happy. And we're happy because, yes, this worked. So I'm just solving. So I proved 2 things now. I proved that, yes, x minus 2 is a factor. And I just proved that that solution on the graph, that 2, that x-intercept, is a solution. Right? If I set x minus 2 equal to 0, there's one of my solutions. The others are left within these coefficients. So if I look at these coefficients, it started as x cubed. That means this is now 3x squared. This is now plus 4x. And this is now plus 2. And let me see. I'm going to pause it and see if this factors quick. So I just kind of quickly went through my head to see if this will factor, and it will not. Even if you try to slide it, you'd have a 6 here, and there are no numbers that multiply to 6 and add to 4, so you'd be done. Now, if this happens, you must go to quadratic formula. I'm going to do that over here. So quadratic formula is negative b plus or minus square root b squared minus 4ac. Oops, I don't want to fill it in. You have this in your notes. Just Google quadratic formula if you don't remember it from earlier in the semester. We did that before you went on break. I think that's the last thing we did before break. All over 2 times a. And a, b, and c are going to come from these coefficients. So everywhere there's a b, we're going to use 4. So negative b plus or minus b squared. 4 times a is 3, c is 2. All over 2 times a. And then simplify wise, negative 4 is going to stay negative 4. Plus or minus, inside the square root, that's 16 minus 24, so negative 8, I believe. So that's going to be, I'm going to do a little side work here. That's the square root of negative 8. And some of you, I made a lot of comments on your homeworks. Negative 8, I can't square root it, but there is a perfect square in it, negative 4. So this is the same thing as the square root of negative 4 times 2. And the square root of negative 4 is 2i. And then this remains root 2. So this is negative 4 plus or minus 2i. Root 2 over 2 times 3 is 6. And then again, a few comments I made on some of your papers. These all reduce. So the 4, the 2, and the 6 are even, so I can reduce them all by 2. So that's going to make that 4 a 2, and that's going to make this 6 a 3. And that 2 is gone. So the final 2 solutions here are x equals negative 2 plus or minus I root 2 all over 3. And that's my solutions, as well as this guy, that x equals 2. And if you go through all of these, I marked on a lot of your papers. I don't have a lot of space here or a lot of time left in my video, but I'm going to post all 4 of these worked out. And you'll see when I bring it up here, the numbers don't match. Because again, this was from a Unit 5 used to be graphing and solving polynomials. We took the graphing and operations off. So this is just factoring and solving by factoring, really, or by division. So here's the problem I just did. I'm going to post this. This was number 11. And there I was trying to factor by grouping, but it didn't work. And there's the same solutions we got. And then for the next ones, this is number 12. I'm going to kind of jump back and forth here. Number 12. X cubed plus 125. And this is the reason I'm posting this and not doing it in the video, is there are many ways you can do this, or usually 2 ways at least. So in number 12, again, this is number 12, you could have factored it using the special pattern, right? And you solve, you get your solutions. But you could have also solved it with division, meaning you could have graphed x cubed plus 125, saw there was an x-intercept at negative 5, and divided it out. And then boom, there you are with that same quadratic that you get the same solution. And I did this for all of these. So many of them you could solve more than one way, and you'll see when you do either way, you get the same solutions. So these are those last 4 problems. Just every single one of them is worked out for you. 26 doesn't factor, so the only way you could do 26 was with synthetic. I'm going to post this video and all these solutions as you're reviewing on Wednesday. Just shoot me a remind message if you have any questions. I'll be around all day.